I discovered something shocking about my brain after years of failed attempts at productivity. Every time I sat down to tackle a difficult project, my brain would literally hijack my attention and drag me toward easier, more pleasurable activities. I thought I was broken until I learned that this wasn't a character flaw. Your brain has ancient survival mechanisms that haven't caught up to modern life, and they're working against your goals every single day. Once you understand how to communicate with these systems, everything changes. Your brain has a security system that's been running the same outdated software for 200,000 years, and it's treating your important goals like life-threatening emergencies. This ancient threat detection mechanism worked perfectly when humans faced actual predators and environmental dangers. Today, it creates chaos in your attempts to accomplish meaningful work. Every time you approach a challenging task, your brain runs it through an ancient threat assessment protocol designed to keep our ancestors alive in dangerous environments. The moment you think about writing that report, preparing for that presentation, or starting that difficult conversation, your brain begins scanning for danger signals. It registers the uncertainty, the potential for failure, the cognitive effort required, and immediately flags these as threats requiring immediate action. This system can't tell the difference between a saber-toothed tiger and a difficult work presentation, so it triggers the same avoidance responses that once saved lives. Your amygdala, the brain's alarm center, doesn't understand modern challenges. It processes cognitive strain the same way it would process physical danger. When you sit down to tackle something difficult, your amygdala interprets the mental effort as a signal that something is wrong, that you're in danger, that you need to escape. The amygdala scans your environment constantly, looking for threats and interpreting cognitive effort as physical danger. This creates genuine stress responses to mental challenges that feel completely disproportionate to the actual task. Your heart rate increases, your breathing becomes shallow, stress hormones flood your system, and your body prepares for fight or flight, all because you opened a spreadsheet or started thinking about a complex problem. Research reveals that when you avoid difficult tasks, your brain's default mode network immediately springs into action, literally pulling your attention toward easier, more familiar activities. This network becomes hyperactive during moments of task avoidance, directing your focus to anything that doesn't trigger the threat response. Your brain starts generating thoughts about checking social media, cleaning your desk, getting a snack, or any activity that feels safer than the challenging task at hand. This threat detection creates a neurochemical cascade that makes hard tasks feel physically uncomfortable, not just mentally challenging. Your brain releases stress hormones like cortisol and adrenaline, creating physical sensations of discomfort, restlessness, and anxiety. The discomfort isn't imaginary or psychological weakness. It's a real biological response to what your brain perceives as a survival threat. Your nervous system activates the same pathways that would help you escape from actual danger. This explains why willpower feels so exhausting. You're essentially fighting against a system designed to override conscious decision-making in perceived emergencies. Your prefrontal cortex, responsible for rational thinking and long-term planning, has to work overtime to suppress the amygdala's alarm signals. Every moment you spend forcing yourself to continue with a difficult task requires tremendous energy because you're battling your own survival instincts. This ancient wiring explains why smart, capable people still struggle with procrastination despite knowing better. Intelligence doesn't override survival mechanisms. Successful people aren't immune to these responses. Your brain doesn't care about your career goals, your deadlines, or your aspirations. It cares about keeping you alive, and it interprets challenge and uncertainty as potential threats to your survival. The more important the task, the more your brain perceives it as risky, and the stronger the avoidance response becomes. Understanding that your brain treats difficult tasks like physical threats reframes procrastination from a character flaw to a predictable neurological response. You're not lazy, undisciplined, or lacking motivation. You're experiencing a normal biological reaction to cognitive challenge. Your brain is doing exactly what it was designed to do, protecting you from perceived danger. The problem isn't your character. The problem is that your survival software hasn't received an update in 200,000 years. This recognition changes everything about how you approach difficult tasks. Instead of fighting against yourself, you can start working with your brain's protective systems. Instead of viewing procrastination as evidence of personal failure, you can see it as your amygdala doing its job, albeit with outdated information about what constitutes actual danger in the modern world. But there's another layer to this system that's even more powerful in sabotaging your goals: your brain's reward prediction machinery. Your brain has a reward prediction system that's constantly calculating the effort-to-pleasure ratio of every activity, and it's rigged against anything that requires sustained mental effort. This internal calculation happens automatically below your conscious awareness, determining which activities your brain will drive you toward and which ones it will resist. Every time you consider starting a task, your brain runs a cost-benefit analysis that weighs the anticipated reward against the required effort, and challenging tasks almost always lose this competition. Dopamine doesn't actually create pleasure. It drives seeking behavior by predicting how rewarding an activity will be, and hard tasks consistently lose this internal auction. Most people misunderstand dopamine's function, thinking it creates good feelings during rewarding experiences. The reality is far more complex and explains why motivation feels so unreliable. Dopamine operates as your brain's prediction engine, estimating future rewards and driving you toward activities that promise the highest return on investment. When your brain calculates that scrolling social media will deliver more immediate satisfaction than working on a difficult project, dopamine pushes you toward the easier option. Your brain's reward system was calibrated for immediate survival needs, not long-term goal achievement, creating a massive mismatch with modern success requirements. This system evolved when humans needed quick decisions about food, shelter, and safety. Activities that provided immediate benefits for survival received priority in the neural reward circuits. The most valuable activities often require sustained effort over extended periods before delivering any meaningful reward. Your ancient reward system can't comprehend why you would choose months of difficult work over immediately available pleasures. Dopamine spikes occur in anticipation of rewards, not during them, which explains why starting hard tasks feels impossible while scrolling social media feels irresistible. The moment you think about checking your phone, dopamine floods your system in anticipation of the social validation, entertainment, or novelty you expect to find. Your brain experiences this anticipatory spike as motivation, pulling your attention toward the activity. When you consider working on something challenging, there's no immediate dopamine release because the rewards are distant and uncertain. Without this neurochemical motivation signal, the task feels unappealing and difficult to begin. Research demonstrates how your brain's energy conservation system actively resists activities that require high cognitive load, treating mental effort like a limited resource to be hoarded. Your brain consumes roughly 20% of your body's total energy, despite representing only 2% of your body weight. This creates an evolutionary pressure to conserve cognitive resources whenever possible. When faced with mentally demanding tasks, your brain activates conservation protocols designed to preserve energy for potential emergencies. This biological energy-saving mechanism makes concentration feel physically exhausting and creates resistance to sustained mental effort. There's a crucial neurobiological difference between motivation and discipline that determines your success with difficult tasks. Discipline requires prefrontal cortex override systems that can function independent of reward predictions. When you rely on motivation alone, you're dependent on your brain's reward calculations favoring the difficult task over easier alternatives. This rarely happens consistently because your reward system prioritizes immediate gratification. Discipline engages different neural pathways that can override reward predictions and energy conservation mechanisms through conscious effort and practice behavior patterns. Your brain's reward circuitry has been hijacked by modern digital stimuli that provide instant gratification, making delayed reward activities feel even less appealing by comparison. Social media platforms, video games, and streaming services are engineered to trigger dopamine releases on variable reward schedules that create powerful psychological hooks. These technologies deliver unpredictable rewards at rapid intervals, training your brain to expect immediate gratification from engaging activities. After experiencing these high-frequency reward cycles, activities that require sustained effort without immediate payoff feel incredibly unappealing and difficult to maintain. This isn't about lacking self-control, but about competing against a system optimized for immediate survival, not long-term success. Your reward circuits evolved to prioritize activities that provided immediate survival advantages in dangerous environments. Self-control was less important than quick decision-making about immediate threats and opportunities. Today's success requires exactly the opposite approach: sustained effort on activities with distant rewards while resisting immediately available gratifications. You're not competing against your own willpower. You're competing against millions of years of evolutionary programming. Recognizing that your brain's reward system prioritizes immediate gratification over long-term benefits explains why discipline, not motivation, becomes the key to achieving difficult goals. Now that you understand why your brain actively works against hard tasks, the question becomes how to work with these systems instead of fighting them. You're not broken, lazy, or lacking willpower. Your brain is simply running ancient software that hasn't been updated for modern challenges, and understanding this changes everything. The threat detection system that interprets difficult tasks as physical danger, the reward circuits that prioritize immediate gratification over long-term success, these aren't personal failures. They're predictable, neurological responses that every human experiences. Instead of battling your brain, you can learn to communicate with its survival and reward systems, turning neurological obstacles into strategic advantages. This knowledge transforms your relationship with difficult tasks from a willpower battle into a brain training exercise, where understanding the system gives you the power to influence it